Okay, this is the review for the Unit 8 test. Let's look at questions 1 through 5. We have a few different functions and we just sketched graphs. So we have a log function here, an exponential, and another log function. Let's look at the exponentials first, since we've had a lot of practice graphing those. G of x is an exponential function that is decreasing. The asymptote is at y equals 0 because there's no number being added or subtracted after here. So we know the graph is going to approach this horizontal line. And if I just check when x equals 0, the y-intercept would be 1. And I know this is a decreasing function because this number is less than 1. So just a quick sketch would look something like this. Alright, now the other exponential function is also has an asymptote at 0 because there's no number being added or subtracted here. So the graph's going to approach 0. Our y-intercept again is 1 because 4 to the 0 is 1. And this is increasing, so it's going to look like this. Now looking at the log functions, log base 4 of x, well that's the inverse of 4 to the x. Log is always the inverse of exponential. So I know that an inverse function means I'm switching x and y, or you could think of it as reflecting it over the line y equals x. So if I were to just sketch the reflection of this graph, it would look something like this. So if I copy that graph over to here for f of x, I have my log function approaching the vertical line x equals 0. Alright, and then k of x, we have natural log of x. Well, we haven't graphed the inverse of that. This is a log function with a base of e. So I know that even if I didn't know how to graph that, I know how to graph y equals, the inverse of this would be e to the x. So this is an increasing exponential function because e is equal to 2.7 and so on. So again, my asymptote here for my original, or for my inverse here of the exponential is at x equals 0. And this is an increasing exponential function, y-intercept of 1. So if I were to sketch the inverse of this, reflecting it over the line y equals x, I would have something that looks like this. So it's going to look pretty similar to the log function we had here. So asymptote at x equals 0, and we have another log function. Alright, now which functions have a vertical asymptote? Well, we can see here functions f and k, because those are the log functions. Horizontal asymptote, that would be functions g and h, because those are exponential. Inverses, well here h and g are, or I'm sorry, h and f are inverses of each other. And which functions have a domain? Remember, domain is x of all real numbers. Both of the exponentials go forever in both directions in the x direction, so g and h.